Enterprise networks currently face over 2,200 cyber attacks every single day. When a breach is successful, the average cost to a business hits $4.45 million. Advanced generative AI and automated scanners bypass user interfaces entirely. They hunt the underlying structured data where the actual value lives. If you strip away the application layer and the web design, you will find a stark, two-dimensional grid of relational data. The exact mathematical rules that make databases highly organized and easily queryable for engineers are the exact same rules weaponized by automated intelligence to extract that data. To defend against modern AI threat factors, database engineers must deconstruct the deterministic mechanics of relational data from first principles. Relational algebra operates in two distinct environments. The data definition language, or DDL, creates the permanent structure of the tables. The data manipulation language, or DML, alters the temporary state of the records inside that structure. DDL architecture enforces strict rules. In MySQL, a table requires a minimum of one column, and every data type is rigidly defined. Engineers must choose between formats like varchar, a variable length type that scales memory to the exact text size, and char, a fixed length type that occupies the exact same byte footprint regardless of the input. These tables show our baseline DML data for this lesson, the account and transact schemas. A database retrieves data deterministically using strict selection queries. The system parses this code and executes exact pattern matching to project only the rows that satisfy the logical condition. Human readers can infer intent from a misspelled word. Database queries are entirely literal. A single missing quote mark in the where clause causes the search to fail completely. This deterministic filtering functions brilliantly for legitimate users. It also organizes discrete data points perfectly for rapid, automated extraction by an attacker. True strategic insight requires connecting distinct data silos through the core engine of SQL, relational linkage. We bridge these silos using joins. A natural join strictly relies on matching columns with identical names in both tables. An equi-join is more flexible. It can compare any two specified columns using a conditional operator. An equi-join links static identity with financial actions. Select ANO, A-name, amount from account A, transact T, where A.ANO equals T.ANO and amount less than 3,000. Account number acts as the mathematical bridge, while the where clause filters out transactions over 3,000. Seamlessly linking personal identity to behavioral data is the greatest strength of SQL. It inherently creates a massive attack surface for personally identifiable information, or PII. PII is any data that can trace an action back to a specific individual. Relational databases synthesize thousands of discrete records into high-level strategic intelligence using aggregation functions. These functions operate on strict mathematical rules. The AVG command calculates the numerical average of a column. The count command tallies the number of values in a column, while explicitly ignoring nulls, whereas count* counts every total row in the output, regardless of missing data. The group by clause clusters identical data points together. This converts a raw chronological list of transactions into a unified summary of distinct categories. The engineering architecture we have built is highly queryable, perfectly deterministic, and mathematically robust. An architecture designed to maximize data accessibility and linkage is structurally undefended against automated systems that abuse those exact rules. Generative AI and large language models, AI systems trained to understand and generate massive amounts of text, are now engaging directly with this relational architecture. AI-powered automated vulnerability scanners bypass graphical interfaces. They rapidly probe codebases and open-source endpoints looking for direct database access. When these automated scanners find a weak entry point, they instantly target unencrypted columns, like the names and transaction amounts we joined earlier, for mass extraction. Criminals are also manipulating the DML layer. They deploy AI-generated deepfakes to beat KYC, know your customer, the mandatory legal process of verifying a client's identity before opening an account. Attackers fabricate highly realistic documents to inject synthetic identities into the database during the insert into phase. Because the data formatting matches the DDL rules perfectly, it bypasses human detection. Large language models also craft personalized phishing and social engineering emails to steal authorized employee credentials, granting the attackers legitimate query execution rights. When an AI-driven breach occurs, it rarely breaks the math of the database. It perfectly executes the relational logic of joins and selections to exfiltrate the data. Relying solely on external network firewalls leaves the data exposed. The primary defense must be architected at the structural schema level. This regulatory document highlights the legal necessity of two principles of responsible AI data handling: data minimization and purpose limitation. The lazy select * command is an extreme liability. Engineers must write queries that explicitly request only the absolute minimum columns required for the immediate task. Sensitive fields require constant PII redaction and encryption. They must be obfuscated at rest. Even if a scanner successfully executes a select query, the resulting payload is useless hash data. Strict access controls act as a structural roadblock to malicious joins. If an AI phishing attack steals an employee's credentials, the database architecture must proactively deny unauthorized equijoins between the identity and financial schemas. The role of the modern database engineer has evolved. It is no longer about maximizing data accessibility. It is about enforcing a rigorous defensive balance between the power of relational queries and the necessity of data privacy.